For centuries, diamonds have been symbols of wealth, beauty, and power, captivating humanity with their brilliance and rarity. But what if entire planets made of diamonds existed in the vastness of space? This once unimaginable concept is now a scientific reality, thanks to groundbreaking discoveries in exoplanet research. Among these extraordinary worlds, one stands out: 55 Cancrii, a planet so extreme that its surface may be covered in shimmering, crystalline carbon. Could this be the ultimate cosmic treasure, a literal diamond in the sky? Located about 41 light-years away in the constellation of Cancer, 55 Cancrii is a super-Earth, a rocky planet significantly larger than our own but still smaller than gas giants like Neptune. What makes it unique is its potential composition. Scientists believe that this alien world is rich in carbon, subjected to immense heat and pressure, possibly transforming its interior into pure diamond. This discovery has ignited imaginations worldwide, raising questions about how such planets form, whether they could hold untold riches, and if they might even be habitable under extreme conditions. Astronomers have long speculated about carbon-rich planets, but 55 Cancrii provides the first real evidence that such exotic worlds exist. Unlike Earth, which is primarily composed of oxygen and silicon-based rocks, diamond planets could be made mostly of carbon, compressed into solid crystalline structures. If true, this would redefine our understanding of planetary formation and geology. How common are these glittering worlds? Could there be other diamond planets waiting to be discovered, some even closer to Earth? But 55 Cancrii is more than just a scientific curiosity. It challenges what we thought we knew about planets in general. Its extreme environment, where temperatures soar thousands of degrees due to its proximity to its parent star, raises questions about planetary survival, atmospheric conditions, and potential alien chemistry. Could diamonds withstand such extreme heat, or does this world hold even more secrets beneath its surface? These are the mysteries that scientists are eager to unravel. Today, we embark on a journey to explore the incredible discovery of diamond planets, focusing on 55 Cancrii as the most stunning example. We will dive into the science behind these alien gems, how they form, and what their existence means for the future of space exploration. Could diamond planets be the new frontier for mining? Will humanity one day travel across the cosmos in search of celestial riches? And most importantly, how does this discovery reshape our understanding of the universe? Get ready for a dazzling adventure beyond anything you've imagined. 1. The Cosmic Jewel. What is 55 Cancrii? 55 Cancrii is an exoplanet unlike any other, a world so extreme that it has fascinated astronomers for years. Discovered in 2004, this super-Earth orbits a Sun-like star in a binary system, meaning its star has a companion. What sets it apart is its extreme proximity to its parent star, completing an entire orbit in just 18 hours. This means a year on 55 Cancrii is less than a single day on Earth. The planet is so close to its star that its surface temperatures exceed 2,400 degrees Celsius, hot enough to vaporize most known materials. Its size and composition make it stand out, roughly twice the size of Earth but nearly 8 times as massive, suggesting a rocky or metallic interior. However, its density and spectral data hint at something truly extraordinary, a carbon-rich composition. Unlike Earth, where silicate rocks dominate, scientists suspect that 55 Cancrii contains vast amounts of carbon, compressed under immense pressure, potentially forming a planetary core made of pure diamond. If this theory proves true, it would be the first known diamond planet, challenging everything we thought we knew about planetary diversity in the universe. The extreme conditions of 55 Cancrii make it one of the most inhospitable yet fascinating planets ever discovered. Due to its close orbit, it is believed to be tidally locked, meaning one side always faces its scorching star while the other remains in perpetual darkness. This creates dramatic temperature differences, with the day side reaching over 2,400 degrees Celsius, while the night side, though still incredibly hot, is significantly cooler. Recent observations from the James Webb Space Telescope suggest the presence of a volatile rich atmosphere, possibly containing elements like carbon monoxide, nitrogen, or even vaporized silicates. Some scientists theorize that the planet's surface could be covered in a molten ocean of carbon, where intense heat and pressure force liquid carbon into crystal formations, constantly creating and destroying diamonds in a violent geological cycle. If confirmed, this would make 55 Cancrii not just a diamond planet in theory but a living, ever-changing world of extreme chemistry and physics, pushing the boundaries of what we consider possible in planetary science. 2. How do diamond planets form? The formation of diamond planets is one of the most fascinating mysteries in astronomy. Scientists believe that 55 Cancrii and other carbon-rich worlds are born in environments vastly different from our own solar system. Unlike Earth, which formed in an oxygen-rich region of the protoplanetary disk, these exotic planets likely originated in areas rich in carbon, allowing for completely different chemical processes to take place. This abundance of carbon, combined with extreme pressure and heat, could have resulted in planetary interiors made almost entirely of diamond. Another possibility is that these planets began as gas giants like Jupiter but lost their thick atmospheres due to their star's intense radiation. As the gaseous layers were stripped away, the solid carbon core remained, evolving into a superheated rocky world. This process could explain why 55 Cancrii orbits so close to its star yet remains solid. If these planets are more common than we think, it could mean that our understanding of planetary formation needs a dramatic revision. Are there entire star systems filled with diamond planets waiting to be discovered? The discovery of diamond planets like 55 Cancrii has sparked speculation about the possibility of entire carbon-rich solar systems, vastly different from our own. If these planets form in regions with excess carbon, then stars with similar compositions could host multiple worlds with diamond-like interiors, leading to entirely new classifications of planetary systems. Some astronomers even suggest that such planets may have geological processes unlike anything seen on Earth, with volcanic eruptions of liquid carbon or seas of molten diamond that shimmer under the intense heat of their host stars. If proven true, these extreme conditions would rewrite what we know about planetary geology and how different worlds can evolve under exotic chemical environments. 3. The extreme conditions of diamond planets like 55 Cancrii are unlike anything found in our solar system, with temperatures and pressures that challenge our understanding of planetary formation. The surface temperatures on the star-facing side can exceed 2,400 degrees Celsius, hot enough to melt metals like iron and platinum. These extreme conditions likely prevent any form of atmosphere from staying intact, meaning that the planet may be continuously losing gases into space. Additionally, the planet orbits its star at an incredibly close distance, completing a full revolution in just 18 hours, a far cry from Earth's 365-day year. Beneath the surface, things become even stranger. Scientists theorize that the intense internal pressure, millions of times stronger than Earth's, could compress carbon into solid diamond, forming vast crystalline structures. These diamonds could make up a significant portion of the planet's mantle and core, creating a world where diamonds are as common as rock on Earth. However, the conditions on 55 Cancrii are so extreme that even if diamonds exist, they might remain buried deep beneath layers of molten carbon and other high-pressure elements. 4. How did 55 Cancrii become a diamond planet? The origins of 55 Cancrii provide clues about how diamond planets might form in the universe. Unlike Earth, which is rich in oxygen and silicate-based materials, 55 Cancrii is thought to have been born in a carbon-rich environment, where carbon was far more abundant than oxygen. This fundamental difference in composition could have caused the planet to develop a crust and mantle filled with carbon-based materials, which under extreme heat and pressure, transformed into pure diamond. Some scientists believe that 55 Cancrii may have once been a gas giant, but as it migrated too close to its star, its lighter elements were stripped away, leaving behind a super-dense, carbon-based core. Another theory suggests that the planet may have formed in an oxygen-poor environment, meaning that instead forming silicate-based rocks like Earth, it accumulated graphite and carbides, which could later compress into diamond. If this is true, it raises the possibility that many other planets in the universe could be diamond-rich, particularly those in systems where carbon was more prevalent than oxygen during planet formation. The study of 55 Cancrii is crucial because it challenges traditional models of planetary composition and suggests that rocky worlds beyond Earth could be vastly different from what we previously imagined. 5. Could there be other diamond planets in the universe? While 55 Cancrii is the most famous diamond planet, it may not be unique. In fact, astronomers believe that diamond planets could be relatively common in certain types of star systems. Carbon-rich stars, which have higher amounts of carbon relative to oxygen, could give birth to entire planetary systems filled with carbon-based worlds. These planets might not have familiar landscapes of oceans and mountains, but could instead feature massive diamond cliffs, graphite plains, and carbide volcanoes. Several exoplanets have been identified as potential candidates for diamond-rich composition, including planets in the systems of pulsars, white dwarfs, and even some main sequence stars. Scientists believe that if a planet forms in an environment with the right carbon-to-oxygen ratio, the natural forces of gravity and pressure could transform its structure into a diamond-rich world. The discovery of more diamond planets could revolutionize our understanding of planetary diversity and even fuel speculation about the potential for mining operations in deep space. Could humanity one day extract diamonds from alien worlds, or will these exotic planets remain beyond our reach? 6. What would standing on a diamond planet feel like? Imagine standing on the surface of 55 Cancrii, though in reality, you wouldn't last more than a second. The crushing gravity would be far greater than Earth's, making every movement 10 times harder. Instead of solid ground, the surface might be a molten sea of carbon, glowing red-hot under the intense radiation of its parent star. If any solid ground exists, it could be a vast diamond-encrusted crust, so tough that even the hardest drills on Earth would struggle to break through. Beyond the extreme heat, the environment would be hostile in almost every way. There would be no breathable air, no cooling winds, just a barren, light-blasted wasteland where carbon atoms are continuously reshaped by immense pressure and radiation. If you looked up, you might see silicate vapor clouds swirling in a sky that never darkens, as the planet is so close to its star that it never experiences night. Surviving on a diamond planet would be impossible without advanced technology, but if we ever develop the ability to mine its riches, such worlds could hold untold wealth beneath their deadly surfaces. 7. Could diamond planets support alien life? The conditions on 55 Cancri seem far too extreme to support life as we know it, but could alien organisms have evolved to survive on such worlds? Traditional life forms, which depend on liquid water and stable temperatures, are unlikely to thrive on a diamond planet. However, some scientists speculate that exotic life might exist in unexpected places, perhaps deep underground, where temperatures and pressures stabilize enough to allow chemical reactions essential for life. Another possibility is that silicon-based life forms could arise in environments rich in carbon and extreme heat. On Earth, all known life is carbon-based, but silicon has similar chemical properties and might serve as an alternative building block for alien biology. If such life exists, it would be radically different from anything on Earth, perhaps relying on molten metal instead of water or drawing energy directly from extreme radiation. While it remains speculative, the study of extreme planets like 55 Cancri helps scientists broaden their search for life beyond Earth's narrow biological limits. 8. How do scientists detect diamond planets? Detecting a diamond planet like 55 Cancri is no easy task. Since exoplanets are so far away, astronomers cannot directly observe their surfaces. Instead, they rely on indirect methods, such as the transit method, where a planet passes in front of its star, causing a tiny dip in brightness. By analyzing the changes in light, scientists can infer the planet's size, orbital period, and even some of its atmospheric components. Another crucial technique is spectroscopy, which involves studying the light spectrum from planet's star to determine the chemical composition of the planet itself. When scientists examined 55 Cancri, they found evidence of carbon-rich materials, leading to the diamond planet hypothesis. Advanced space telescopes like the James Webb Space Telescope are now helping astronomers gather even more precise data, refining our understanding of planets that may be composed of exotic materials like graphite, carbides, and even diamond. 9. Could future space missions visit a diamond planet? The idea of sending a mission to 55 Cancri is currently beyond our technological capabilities, but that doesn't mean it's impossible. At 41 light-years away, reaching the planet with today's fastest spacecraft would take hundreds of thousands of years. However, future propulsion technologies, such as nuclear fusion, antimatter drives, or even theoretical warp drives, could make interstellar travel more feasible. If humanity develops the ability to travel such distances, 55 Cancri could become a prime target for exploration, especially if its diamond-rich nature is confirmed. Robotic probes could be the first to make the journey, equipped with advanced drilling and analysis tools to sample the planet's surface. If technology advances further, human missions might follow, using advanced heat-resistant suits and underground shelters to survive the planet's brutal conditions. Whether for scientific discovery or the potential for interstellar mining, the allure of a diamond planet could drive future generations to attempt the impossible. 10. What could diamond planets teach us about the universe? The discovery of 55 Cancri has expanded our understanding of planetary diversity, proving that rocky planets can form under wildly different conditions. By studying worlds rich in carbon, scientists can refine theories about how planets evolve and what kinds of materials make up alien worlds. If diamond planets exist in abundance, they might challenge existing models of planet formation and suggest that the universe is far stranger than we ever imagined. Additionally, the existence of diamond planets raises questions about the rarity of Earth-like conditions. If many rocky planets are carbon-based rather than silicate-based, then habitable worlds like Earth could be far more unique than previously thought. By continuing to explore exotic planets like 55 Cancri, we may not only unlock the secrets of planetary formation but also gain insights into the potential for life beyond our solar system. The discovery of 55 Cancri and other potential diamond planets is only the beginning of a new chapter in planetary science. As telescope technology improves, scientists will gain better tools to analyze these fascinating worlds in greater detail. Future missions, such as the James Webb Space Telescope and next-generation exoplanet surveys, could provide direct evidence of diamond-rich surfaces, unlocking secrets hidden beneath their molten atmospheres. Could we one day send robotic probes or even humans to explore these alien gems? The possibilities are endless. Beyond their scientific importance, diamond planets raise intriguing economic and philosophical questions. If a planet-sized diamond were accessible, would it revolutionize the gemstone market or make diamonds worthless? Would interstellar mining become a reality, with corporations and space agencies racing to claim cosmic treasures? The ethical and practical challenges of harvesting resources from distant worlds would require international agreements and new space exploration strategies. But perhaps the most profound impact of these discoveries is how they reshape our perception of the universe. Every new exoplanet found expands our understanding of what's possible in nature. From lava worlds to ice giants, from rogue planets to diamond-rich super-Earths, the cosmos is more diverse and astonishing than we ever imagined. What other incredible secrets are waiting to be uncovered? Could there be even more exotic worlds beyond our current reach, composed of materials we've never seen before? As humanity takes its first steps toward interstellar exploration, discoveries like 55 Cancri remind us that the universe is a place of endless wonder. Whether or not we ever set foot on a diamond planet, the knowledge we gain from studying them will continue to inspire future generations. So keep looking up, because the next great discovery may be just beyond the stars. Like and subscribe for more insightful updates.